Hi everyone, today we will see a problem from alternating current. So the question goes as an electric bulb is designed to consume 55 watts of power when operated at 110 voltage. It is connected to a 220 volt and 50 Hz AC source, line AC source through a choke coil in series. What should be the inductance of the coil for which the bulb gets the correct voltage? So there's an AC source. Let me try it here. So there's an AC source of 220 volt and 50 Hz, and it has a bulb connected to it, and there's also a choke coil connected to in series to it. The bulb has a power of 55 volt and 112 volt, and there's also a choke coil. The choke coil is nothing but a inductor with large inductance and a very small resistance R, and since there is no resistance of choke coil given, so we can ignore this R. So we have to find this inductance L such that this bulb gets the rated voltage, that is 110 volt. So we have to find the inductance of this choke coil such that it gets a voltage of 110 volt. So for that we have to find XL, because only in the formula of XL we have inductance. So from this only we can find inductance. So we have to know omega as well. So omega can be easily found because it has given the question that the frequency is 50 Hz. So 2 pi f, there is 2 pi into 50 will give you 100 pi. So we have to find this XL as well. So we have to find this XL. So for that you need the voltage across the choke coil as well. So we have to find the voltage across choke coil. So let's find. So the total voltage is 220 volt, and the voltage drop across the resistor, that is the bulb, is 110 volt, and the across the choke coil is what we have to find. So it will be equal to total voltage square will be equal to the total voltage across bulb plus total voltage across inductor. Bulb is nothing but a resistance, so I mentioned R here. Now we have to find this VL square. So VL square will be equal to V square minus VR square. So V square is 220, the whole square, minus VR square is 120, the whole square. Now I can simplify. It's in the form of A square minus B square. So I can write this as A plus B into A minus B. So this will be 220 plus 110 into 220 minus 110. So this will be 330 into, this will be minus 110. So this will be 110. This is VL square. Now we have to find VL, that is nothing but the root of 330 into 110. Now I can write this 330 as 110 into 3 into 110. 3 into 110 is 330. So I have written it like this. So there are two 110, so I can take 110 out of the square root and root 3. So this will be the VL. So we have found the voltage across the choke coil. Now we have to find the inductive reactance. So to find the inductive reactance, we also need current, because in the formula voltage across the inductor is equal to I into XL. So we have to find this I. I is nothing but the current flowing through the circuit, and the current flowing through the bulb as well as the inductor will be equal because it's a series circuit. So we can find. So if we are able to find the current that is flowing through the bulb, that will be the current that is flowing through the inductor also. So we know that V is equal to IR. So this will be resistance of the bulb, and this will be resistance of the bulb, and this is the voltage of the bulb. Voltage of the bulb is given as 110, and resistance of the bulb we have to find. In the question it is given that power is equal to 55 watts. So we know that power is equal to V square by R. So 55 is equal to V square is 110 into 110 by R. 110 into 110 by R. So R will be equal to 110 into 110 by 55. So this is 2. So R is 220. So the resistance of the bulb is nothing but 220 ohm. So we can find the current I. So I is equal to 110 by resistance of the bulb is 220 ohm. So 220. So I is equal to 1 by 2 ampere. So this is basically RMS value. So that is 1 by 2 ampere. Now we have to find the inductance L's. We have already found VL, so we can find XL through this relation. So XL is equal to VL by I. VL is nothing but 110 by root 3. 110 by root 3 into 110 into root 3. So 110 into root 3 into I is 1 by 2 ampere. So if we I is 1 by 2 ampere. So if we this 2 will go to numerator. So XL is 223. 220 into root 3 ohm. So we have to find this L. We have already found omega as well as XL. So we can substitute here. XL is equal to omega L. L is equal to XL by omega. So XL XL is 220 root 3. So 220 root 3 divided by omega. Omega is nothing but 100 pi. So pi is nothing but 220 root 3 divided by pi is 3.14. Now if I multiply a 100, it will become 314. So if I simplify this, I will get an answer of 1.2. So inductance is nothing but 1.2 Henry. So this is
Take my hands now. You are the